Good morning. In this lecture, I am Varalakshmi, Professor, Department of Civil Engineering from Mari Lakshman Reddy Institute of Technology and Management. In this lecture, we are going to discuss the types of dams. So, the dams are divided into four types depend on their material purposes. So, the classification is based on the purposes or uses. So, first one, classification depend on its use, dam use. In this category, they are divided into three types. First one, storage dams. That means to store the water and utilize that water later periods. So, examples gravity dam, earth dam, rockfill dam, arch dam, like that. Second one, diversion dams. The diversion dams are utilized for to divert the water. Okay, the examples weights and barrages. And third one, detention dams. Detention dams are constructed nearby the major reservoir or to store the water. Example, dike, water spreading dam, debris dam. The second classification is depend on the design of the dam, hydraulic design of the dam. In this, there are two types of dams, overflow dam, non-overflow dam. Overflow dams are the water overflow from the dam. Non-overflow dams are the water did not overflow from the dam. Example of non-overflow dams are earth dams, rockfill dams. Next, classification by materials. So, materials are majorly divided into two types, rigid material, non-rigid material. If dams are constructed with rigid materials, then it is called the rigid dams. Example, gravity, arch, buttress, which are constructed with steel, concrete, like that. It's non-rigid dams are constructed with non-rigid materials like soil, gravel, pebbles, like that. Examples, earth dam and rockfill dams. Last category, dams are divided on, depend on their height, low dams and high dams. First, we will start with classification of dams based on use. Storage dams. It is the most common type of dams constructed for impounding water behind it during excess supply to be used in the periods of deficient supply. The major purposes of storage dams are irrigation, hydropower, water supply, recreation, like that. Flood control, like that. Next, diversion dams. It raises the water level for diversion into other conveyance system for irrigation, municipal or industrial uses. These dams are smaller height. No reservoirs are formed behind the dam structure. Example, weights and barrages. Barrages, Prakasam barrage, Dhavaleswaram barrage, like that. Next, detention dams. A detention dam is constructed to store water during floods and release it gradually at a safe rate. When the floods recedes, this flood damage downstream side is reduced. There are two types of detention dams, with outlet and without outlet. Next, hydraulic design classification based on hydraulic design. First category, non-overflow dams. A non-overflow dam is the one in which the top of the dam is kept at a higher elevation than the maximum expected high flood level. Water is not permitted to overtop the dam in non-overflow dams. Example, earth dams, rockfill dams, gravity dams. If what happens if the water is overflow on the dam, the structure of the dam will collapse. Next one, overflow dams. An overflow dam is the one which is designed to carry surplus discharges, including floods also, over its crust. Its crust level is kept lower than the top of the other portion of the dam. Since water glides over its downstream face, it should be made of such a material which is not easily eroded by flowing water. Such dams are generally made of concrete. So see the figure. This one is figure A represents the non-overflow dams. Figure B represents the overflow dams. Okay. Next, classification according to material, rigid dams and non-rigid dams. Rigid dams are those which are constructed of rigid materials such as masonry, concrete, steel or timber. Rigid dams are classified into following types. Gravity dam, which is the combination of masonry, concrete or masonry individually or concrete. Arch dam, same material. Buttress dam, concrete material. Steel dam, constructed with steel. Timber dam, constructed with timber. Non-rigid dams are those which are constructed of non-rigid materials such as earth and rock fill materials. The most common types are earth dam, rock fill dam, combined earth and rock fill dams. So next, based on the height. If the dam height is low, it is called low dam, and dam height is high, it is the high dam. When it is called low, the height of the dam is calculated with equation H equal to F by W into rho minus C plus 1, where F allowable stress, W specific weight of water, rho specific gravity of dam, C uplift pressure intensity coefficient. The detailed calculation will discuss in the designing of gravity dams. So the height of the dam is less than that given by above equation, then it is called the low dam. If the height of the dam is more than that given by the equation, then it is called the high gravity dam. So first, what is the gravity dam? A gravity dam is the one in which external forces such as water, silt, uplift force, etc. are resisted by the self weight of the dam itself. So the weight of the dam plays a major role in the stability of the dam. That's why it is called the gravity dam. A gravity dam may be constructed either of masonry or of concrete. Masonry gravity dams are nowadays constructed of only small heights. All major and important gravity dams are constructed with concrete only, because concrete is the stable structure. A gravity dam may be either straight or curved in plan. Concrete dam is constructed with plain concrete. Its own height provides resistance to the forces exerted on the dam. So, but for this type of dams construction, a very hard rock foundation is needed to bear that structure. It needs a very hard rock foundation. Masonry gravity dam constructed of stone masonry. That means stone and mortar will be used. Nowadays constructed for small heights only. In past, a number of large and important dams were constructed with masonry. Example, Krishnarajasagar, Tungabhadra dams. What are the advantages of gravity dams? Gravity dams are relatively more strong and stable than the earth dams or any other dams. They are particularly suited across gorges having very steep side slopes. Gravity dams can be adapted for use as overflow dams. Gravity dams can be constructed of any height provided suitable foundation exists. These dams are constructed in those areas of high rainfall because it bears a more pressures. The dam is very strong and bear the more water pressures. A gravity dam requires least maintenance. Once after constructing, the maintenance is very less, but initial construction cost is more. The failure of a gravity dam is not sudden. It gives enough warning time. But in the earth dam's case, the fail is very sudden. Within minutes, it collapses. But gravity dams take some months of time. Gravity dam is cheaper in the longer run since it is more permanent structure. Benefit cost ratio is always higher. Deep set sluices can be used in gravity dams to retard the sedimentation or silt deposits. If more benefits are there, some disadvantages also there in gravity dams. That are, the dams can be constructed only on sound rock foundations. They are unsuitable on weak foundations. The initial cost of gravity dam is always higher than the other dams. They require skilled labor and mechanized plants. If mechanized plants for manufacturing and transporting mass concrete are not available, then a gravity dam may take more time to construct, more time and more cost also. It is very difficult to increase the height of the dam subsequently unless provision is made in the dam. Okay, so these are the disadvantages of gravity dam. In second unit gravity dam, we will discuss detailed designs. Just here we are giving each type of dam advantages and disadvantages. Next, coming to arc dams. An arc dam is a dam curved in plane and carries a major part of the water load horizontally to the abutments by arc action. The balance of water load is transferred to the foundation by cantilever action because the top shape of the dam is in arc shape. So the cantilever action takes place. What are the advantages of arc dams? There is difference between gravity and arc dams are the shapes. Gravity dams are constructed in the straight shape on the top, but in arc dams, the shape of the dam wall is in curved shape. But in gravity dam, the shape of the wall is straight wall. In arc dams, the shape of the wall is arc shape. Why it is means the shape depends on the valley shape. V-shape valley, U-shape valley. So depend on valley shapes, we are go for straight gravity dams or arc dams. What are the advantages of arc dams? Arc dams are particularly adapted to the gorges where the length is small in proportion to height. For a given height, the section of an arc dam is much lesser than a corresponding gravity dam. Because of much less base width, the problem of uplift pressure is very less. Arc dam can be constructed on moderate foundations because only a small part of water load is transferred to the foundation. Next, what are the disadvantages of arc dams? It requires skilled labor and sophisticated farm work. Special designs are required because the shape of the wall comes in arc shape. So special designs are required. The speed of construction is normally slow. Requires very strong abutments of solid rock capable of resisting arc thrust. Next, buttress dams. Third type is buttress dams. Gravity dam, arc dam, buttress dams all are rigid materials. A buttress dam consists of a number of buttresses or piers dividing the space to be dammed into the number of spans. That means the dam wall is divided into spans. In arc dam and gravity dam, the wall is a single span. But in buttress dam, the wall is divided into different spans. To hold up water and retain the water between these buttresses, panels are constructed of horizontal arcs or flat slabs. When the panels consist of arcs, it is known as multiple arcs type buttress dam. If the panels consist of flat slab, it is known as deck type buttress dam. So you can see the buttress actions, sectional elevation and deck type and multiple arc type. So these are the different types of buttress dams. Next, what are the advantages of buttress dams? A buttress dam is less massive than a gravity dam. Hence, foundation pressures are less in the case of a buttress dam and it can be constructed on weak foundations. The water load acts normal to the inclined deck. Hence, the vertical component of the water load stabilizes the dam against overturning and sliding. Buttress dam possess a factor of safety much greater than that obtained in a gravity dam. The ice pressure is relatively unimportant since the ice tends to slide over the inclined upstream deck. In the case of a buttress dam, further rising of the height is possible and convenient by extending buttress and slab as shown in figure. So these are the buttress heights. So stage 1 height, stage 2 height, stage 3 height. Next, currently buttress dams are used where a future increase in the reservoir capacity is contemplated. If we want to increase the capacity like Almaty, initially the Almaty capacity is less. After some years, the height of the Almaty dam is raised. So like that, we want to increase the capacity, then we go suggest for buttress dams. Powerhouses and water treatment plants can be housed in between buttresses, thus saving some cost of construction. The amount of concrete used in buttress dam is about 33 to 50% of the concrete used in gravity dam of same height. So material also take very less quantity compared to gravity. However, cost of construction is not low in that ratio because of the increased cost of reinforcement and farm work. The material will decrease, but the construction cost is same as gravity dam. Access is possible to the back of upstream face and foundations between buttresses for periodic inspection and subsequent operations like grouting and drilling of pressure relief holes. Next, what are the disadvantages of buttress dams? It requires a skilled labor and the shuttering concrete ratio are greater than for solid dams. Deterioration of upstream concrete surface has serious effects on buttress dams with very thin concrete face. Buttress dam is susceptible to the damage which depends on the thickness of the upstream surface. Next type of dams are steel dams. The steel dams are constructed with a framework of steel with a thin skin plate as deck slab on the upstream side. Steel dams are generally of two types, direct strutted type and cantilever type. So, direct strutted type steel dams has the load on the deck plate is carried directly to the foundation through inclined struts. In coming to cantilever type, the section of the bench supporting the upper part of the deck is formed into a cantilever truss. This arrangement introduces a tensile force in the deck girders which is resisted by anchoring the deck girder into the foundation at the upstream toe. What are but steel dams are less cost, but in the world, 2-3 steel dams are only present. So generally preference is less for steel dams. Greater speed in construction can be achieved with modern methods of steel fabrication. They have been found to be cheaper than other rigid dams. Stresses in steel dams are more deterministic, hence section can be designed economically. They have greater flexibility to resist unequal settlement without excessive leakage. They are not affected by frost action. Leaky joints, if any, can be repaired more easily by modern welding processes than in hollow concrete dams. The major disadvantages of steel dams are lighter, hence are not adaptable to absorb the shock from vibrations of spilling water. The life of steel dam is known to be shorter than a concrete dam. Steel dams require greater and more constant maintenance than concrete dams. They have to be anchored at foundation, which is difficult and precarious. There is considerable concentration of bearing stresses. Next, last type is timber dams. A timber dam is constructed with a framework of timber truss and beams with a timber plank facing to resist water pressure. A timber dam is a temporary dam with a lifespan of 10 years or so. Well-designed, constructed and maintained timber dams may last for 30 to 40 years. They are suitable at places where timber can be available in plenty. Timber dams are normally found to be of three types: A-frame type, rock-filled crib type, beaver type. So in this, A and beaver types are non-overflow type, rock-filled type is overflow type. So A-frame type timber dam consists of 5 component parts: sills, struts, walls, studs, lagging, etc. The sills should be fastened to the wedge rock by wedge bolts or anchor bolts. The lagging should not be less than 5 centimeters thickness. So this is the design of A-frame type timber dam. Next, rock-filled crib type timber dam. A rock-filled crib type timber dam square or round timber cribs are drift bolted together. The timbers are spaced about 2 to 2.5 meter center to the center both ways. The space between them is filled with rock fragments or boulders. In the case of rock foundation, the bottom crypts are pinned to the rock foundation. So this figure shows the type of design of rock filled crypt type timber dam. Next, beaver type timber dam. This type of timber dam is lowest in the cost if plenty of timber is available. Okay, so this is the type of beaver type. Next, advantages and disadvantages of timber dams. Cost is low, suitable for any type of foundation. Where only temporary dams are to constructed, timber dams are more suitable. Greater speed in construction can be achieved. Disadvantages: high maintenance cost, life is short, suitable only for small heights, greater seepage losses through the body of the dam. Next, non-rigid dams are earth dams. Earth dams are made of locally available soils and gravels and are most common types of dams used up to moderate heights. Depending on the method of construction, earth dams can be divided into two types: rolled fill dam, hydraulic fill dam. In rolled fill dams, embankment is constructed in successive mechanically compacted layers. In the case of hydraulic fill dams, the materials are excavated, transported, and placed by hydraulic methods. Next type, rolled fill dams, are divided into three types. Homogeneous embankment dam consists single type material. Zoned embankment dam consists of more than one type of material. Diaphragm embankment type, modification of homogeneous type. Okay, so these are the different zone dams. Zones, different zones: pervious shell, impervious shell, so so all these are the different types. Next, coming to rock fill dam. A rock fill dam is an embankment which uses variable sizes of rock to provide stability and an impervious membrane to provide water tightness. The rock fill dam has four fundamental parts: dumped rock fill at the downstream, upstream rebel cushion, upstream impervious tracing resting on the rebel cushion, upstream cutoff to check under seepage. So these are the different parts of the rock fill dam. Next, combined earth and rock fill dam. Combined earth and rock fill dam is that type of rock fill dam in which the upstream rebel cushion consisting of derrick laid by rock is replaced by hydraulic earth fill. That means you can see the arrow. So the impervious membrane in rock fill dam is replaced with hydraulic fill. So then it is called the combined earth and rock fill dam. What are the advantages of earth and rock fill dams? Earth dams can be constructed almost on any type of available foundations. However, rock fill dams impose some restriction on the quality of foundation, but they are much less rigid than those required for any other type. They can be constructed rapidly with relatively unskilled labor and with materials available on the spot. Hence, it can be constructed even under feminine relief work. They are generally cheaper than other types. They can be subsequently raised in height without much difficulty if such a need arises in future. The disadvantages of earth and rock fill dams are: they are more vulnerable to damage by floods and fail suddenly without sufficient warning. Sudden failure occurs. They cannot be used as overflow dams. Separated spillways are to be provided at some site away from the dam, because if we provide overflow spillways on the top of the earth dam, the water pressure, due to the water pressure, the upper part of the soil will be eroded. So dam stability is decreased. That's why we should not provide overflow of the dams. In earth dams, we provide some separate spillway structure. They are not suitable at locations where heavy downpour is more common, because earth dams does not arrest the heavy runoff. They require heavy maintenance cost and constant supervision. Initially, construction cost is less, but maintenance cost is more in earth dams. In gravity dams, initially construction cost is more and maintenance cost is less. So these are the different types of dams. Depend on the types of valleys, soil and hydrological factors, the type is selected and constructed. Okay, thank you.